Good evening to everyone present here. Is it audible to all of you? Okay. So I welcome you all for this wonderful session and Tech Hour 21. So NoviTech R&D Private Limited. So what's this program? 3 days program. So yesterday we completed the software development program, and today the electronics department. So it's a virtual event on the best cutting edge technologies for the next decade. So, and it's with great pleasure and pride that NoviTech launches the Tech Hour series. The theme of the 90-minute session is create an awareness on recent cutting edge technologies and create an impact of emerging technologies in upcoming digital world system. Okay, and once again I welcome you all for this session. So, and before I enter the session, I would like to introduce ourselves to all of you. So we are NoviTech. It's a technological research and development company. We contribute to the development of society and industry through the technology and services. So we leverages advanced technology and insights of technical experts to deliver the integrated solutions. So we are a team of experts in artificial intelligence, Internet of Things, and augmented reality, and virtual reality, and etc. And now we are manufacturing the product for top industries, and we are training, we are giving a guidance for the final year students of engineering and arts college students for their own technical improvement. Okay, so today electronics and communications. So what is the important and cutting edge technologies are appeared in this electronics domain? So let's talk about this. So basically the electronics engineering is a form of engineering and associated with the electronic circuits and devices and the equipments and the systems that use them. And many people have a careers in electronics engineering and find their jobs absorbing and interesting, and they provide interesting challenges that ensure to motivate them for further their future. Okay. So there will be a lot of scope for electronics engineers. So when they have a adequate knowledge and innovative skills in their field of the study or specializations, and ECE is the best engineering branch nowadays in India also and abroad. So if we tell about a government sector, then it has broad scope in highly reputed organizations like ISRO and DRDO and DMRC, BRC and NAL team and SSC, GATE, IES, and most of the companies are required electronics engineers. So it's based on their own interest according to their field or branch. Okay, so let's talk about the what are the important and cutting edge and the top technologies appeared in this electronics domain. First, we all know about the embedded systems. So it's a very important one. So without embedded, nowadays there is no world. So because from our daily life, from the morning to evening, morning to night, from our wake up to sleeping, so this all the times is totally based on the electronics. For example, if you are wake up, so that alarm, so alarm will be used for the wake up, and after that you need to move from your home to office or school or colleges, then you need a motorcycle or car, and it's totally depends on the embedded system. And after in your workplaces you have a computer So this is also the embedded systems, and evening. So each and everyone is related to the embedded systems. Okay, so as we all know, it is a combination of hardware and software. And apart from that, so they have more definitions. So let's quickly define the embedded systems as a computer system with a dedicated function with a larger mechanical or electrical system. For example, say in our car or our motorbike, so we have one fuel level indicator, and it's also the embedded system. So because that petrol tank or diesel tank contains some sensor, and these sensors detect the level of that particular petrol or diesel, and this level is indicated to our dashboard. Okay, so this is all those also the embedded system, but this embedded system is appeared on some mechanical or some electrical systems. Okay, so that gives us two important criteria for understanding what an embedded system. So first one is the system must be a computerized, so meaning that it functions with a microprocessor or microcontroller. That is a very important part of every embedded systems or every electronic systems. Microprocessor and the microcontroller. So it's like our brain. Okay, so basically it's called as a processor, and this process contains a two part. One is a microprocessor and another is a microcontroller, and there is some little differentiations in that. So microprocessor between the microprocessor and the microcontroller. Okay, so this embedded system is embedded in something else. So it's a part of larger device that serves a function on its own. For example, I already told that this petrol level indicator. Okay, so and an additional characteristics of embedded system is that they frequently operate in real time. It's very important. So it means so that the system controls the environment by receiving the data and processing it and returning this result quickly enough to affect the environment within a reasonable time duration. So after milliseconds or even microseconds. Okay, so this is the example for that. Our AC, air conditioner. So because these air conditioners have some lot of sensors for identify the temperature of that room. Okay, and after identify the temperature level, so it will processing and it will analyzing the temperature level, and finally it's change the environment, it's reduce the temperature level of that particular room. Okay, so and this is the two criterias. Okay, so for these embedded systems we have some software connections and we have some hardware connections. Okay, so we need electronic devices as well as we need a software program. Okay, so for interconnect that electronic devices, definitely we need a one communication system. No? Maybe so either it's communications like wired connections or wireless connections. Okay, so first initially let's talk about the wired connection. So the fantastic wired protocol is a CAN. Okay, it's one of the protocol, so we can call this as a CAN bus. So the robot bus is originally developed the controller area network for in-vehicle networks. So because if you take our car, if any one of the vehicle, any one of the automobile, so it have a lot of electronics. The simple example, if you are open the door, it will indicate it in your dashboard. If any, if you are turn on the left indicator or light indicator, so it's also connected to the dashboard, and each and everything inside of that car is connected to the dashboard. Okay, but the main part of this CAN is reduced the wire connections. Okay, so in the past before the CAN protocol, so the mostly the automotive manufacturers connected the electronic devices in vehicles using by the point-to-point connectors, point-to-point wiring systems, and these manufacturers began using more and more electronics in the vehicles, so which is resulted in bulky wire harnesses and that were heavy and expensive. and they then replaced the dedicated wiring with in-vehicle networks, so which reduced the wiring cost and complexity and weight. Okay, the main motto of this CAN protocol is reduce the wire connections. That's it. Okay, so let's talk about there's some features about the CAN protocol. Okay, so just see the image. The first image is denoted the without CAN, and the second image denoted the with CAN. So just see the wide connections. Okay, so and first this is the low cost and lightweight network. So this CAN bus provides an inexpensive, durable network that helps the multiple CAN devices communicate with one another. Okay, so an advantage is that electronic control units, that's called ECUs, can have a single CAN interface rather than analog and digital inputs to every device in the system. So this decreases the overall cost and weight in automobiles. And the second important thing is that it's a broadcast communication. Broadcast communication means nothing. This the structure of the CAN protocol is allows the modifications to CAN networks with minimal impact. And the next is a priority. It's a very important for every electronic and embedded systems. Priority. So that's called a interrupt. Okay, we can call this as an interrupt. Okay, so every message have some priority. So if two nodes try to send a message simultaneously to the particular controller or particular node, the first message or the higher priority message gets transmitted, and the another one gets a lower priority, means it gets postponed. So that is the priority. Okay, so it gives the priority to the higher priority. Okay, so it first allows the communication for higher priority messages, and then only it's moved to the lower priority. Okay, so and next the error capabilities. So it's also the important. So this CAN bus specifications includes the cyclic redundancy code, that's called CRC, to perform the error checking on each frame's contents. So each and every frames are checking with the error capabilities. Okay, so this is some wired connections, and let's talk about the wireless. The another one, wireless sensor network, that's called WSN. Okay, so basically this wireless sensor networks can be defined as self-configured and infrastructure-less wireless networks to monitor the physical or environmental conditions such as temperature, sound and vibration and pressure and humidity and motion and pollutants, and to cooperatively pass their data through the network to the some main locations. Otherwise we can call this as a master node. Otherwise it's called as a sink, so where the data can be observed and analyzed. Okay, so see, so here this 4 red color dot mentioned as the slaves, so and each and every red color dots have some sensors. Okay, so and this sensors is connected to this one particular node. Okay, and this all the particular slave nodes is connected to the only one master node. Okay, so and there is a lot of types are available for these connections. So we can for example the delta connections and star connections, and there is a lot of connections are there. So this is the first network, first slave node. So it contains some sensors and it collects the data regularly, and this data is transmitted to this the main master node. The same process here and also here and also here. Okay, so and the main part of this wireless sensor network is only for some short places, short areas. It's some local areas, that's it. Okay, so and let's talk about the communications tool. So we can use the radio frequency for their communications. So it's this red color dot is have some radio frequencies tool. It's like a radio transmitter, and this also have some radio transmitter, and this master node have some transceiver. So its capability of receiving the data and as well as the transmit the data. Okay, so and we can use any one of the wireless protocol here, like the Li-Fi and the radio frequency. Li-Fi means it's nothing, it's a light fidelity. Okay, so we can share the data through the light. Okay. For example, if you are using a radio frequency, so it has some disadvantages. So like it's affect our brain. It's affect the some small size bats and insects like that. So it have a high frequency. Okay. So for avoiding these disadvantages, we can use the Li-Fi, light fidelity. So it's only transmits the lights, and in these lights contains some data. As like our IR. Okay, so let's talk about the applications of wireless sensor network. So we can use this wireless sensor network in military applications. So it's like an integral part of military command and control the communications and computing and intelligence and battlefield surveillance and some targeting systems. So we can share the data to some military applications using by this WSN network. And next, the transportations. So the real-time traffic information is being collected by the WSN network to later to feed the transformation models and alert the drivers of congestion and traffic problems. So and healthcare. So inside of the hospital, we can use this wireless sensor network. So we can attach this wireless sensor node to each and every patient, and this sensor will collect the information from the patient's body, like temperature and heartbeat and blood pressure level, and this all the data is shared to the particular master node. So this process is very easy to analyze the patient's details for the doctors. Okay, so it's mostly for the disabled or integrated patient monitoring systems and diagnostics and drug administrations and telemonitoring of human psychological data and tracking and monitoring the doctors or patients inside the hospitals. Okay, so we can use the wireless sensor network in hospitals. And the environmental sensing, so it's a very important one. So because environmental monitoring is the most important one nowadays, because the most pollutions are there. We need to identify all the pollution criteria and we need to avoid them all. Okay, so the term environmental sensor networks has developed to cover many applications of WSNs to earth science research. So this includes the sensing oceans and glaciers and forest. So and so I will tell some other major areas. So air pollution monitoring. So we can use this for air pollution monitoring and the water monitoring, water condition monitoring, and forest fire detection and greenhouse monitoring and landslide monitoring. Okay, so and let's talk about the structural monitoring. So it's very useful for the constructions. So because the wireless sensors can be utilized to monitor the movement within the buildings and the infrastructure such as bridges, flyovers and embankments and tunnels. So it's enabling the engineering practices to monitor the assets remotely without need for costly sites visit. These all the sensors collect the data from that particular bridge, and this bridge data is stored to any one of the master node, and we can easily monitor that. And after identify that, we can apply some other technologies like AI, artificial intelligence. So I will tell about this AI in later. And we can use this to the industrial monitoring for identify the hazardous gases and some machine identify the fault of the machines. Okay. So and agricultural sector, this is the environmental agricultural sector. So using by this wireless sensor network, so it frees the farmer from the maintenance of wiring in a difficult environment. So because nowadays all of the farming areas are have a some digitalized, it's have some digitalized techniques for identify the moisture levels. They can use the moisture sensor, and based on that moisture level they can automatically sprinkle the water, and it's automatically identify the temperature level and humidity level. Okay, so this wireless sensors network is reduced the wires in agricultural lands. Okay, and see guys, this wireless sensor network is only for some particular areas, so some limited areas. So because here we using the some low level of wireless communications protocols, like as I'm told already, the radio frequency or the Li-Fi, and then so we can use the Bluetooth communications. Bluetooth is also the short range, and we can use the Wi-Fi also. Okay, but we need to control and we need to monitor these all the things from everywhere. That is the thing, that is the Internet of Things. So we can call this Internet of Things as the next stage of internet and next evolution of internet. So before the Internet of Things, we are using some devices, some computer devices, some system that capabilities with a network. So we're only using these types of devices for internet. But after the Internet of Things, it's changed the internet world. So because the meaning of that is Internet of Things, Internet for things. So we can connect all the things to the internet. For example, if you take your own chair or table, so we can connect this table and chair into the internet. So but this is a normal things, so it's a physical, normal physical object. We can connect this normal physical object into the cloud, into the network. So that's called the Internet of Things. For this we need the simple things, the sensors and the actuators. Okay, the main part of Internet of Things is controlling and the monitoring. So we need to control the control any one of the things, and we need to monitor any one of the things. For controlling process, we can use the actuators like motor or other some actuating devices. For monitoring that particular things, we need a sensors for sensing that. Okay, so we could also define this IoT as the next stage of internet. No? Okay, so and let's talk about what are the applications of this Internet of Things. And before that, so just see, this is the differentiations between the wireless sensor network and the Internet of Things. Okay, so this is one of the wireless sensor network, and this is one of the wireless sensor network, and these all the slave nodes are connected to the particular master, and this all the slave nodes are connected to the particular master. And if we are applying the Internet of Things to these nodes, we can connect to the master, we can collect the data from that particular master, and we can store this into the cloud using by the internet. And each and every masters can send the data through the internet to cloud. Okay, and after that, after uploading, after collecting the data from the sensors nodes, we can easily monitor from our mobile phone. So we need to connect our mobile phone into the particular cloud, and then we can access that particular nodes, particular master and particular nodes. We can collect the information from that particular node, and we can activate the particular node. Okay, so this is the difference between the wireless sensor network and the Internet of Things. Okay, and the applications, the ever first application of Internet of Things is a smart home. So this smart home is clearly stands out the ranking as highest Internet of Things application on all measured channels. So more than 60,000 people currently search for the term smart home each month. So this is not a surprise, but this is the important one. So the IoT analytics company database for smart home includes the 256 companies and startups. So and more companies are active in smart home than any other applications in the field of IoT. So the total amount of funding for smart home startups currently exceed $2.5 billion. It's just $2.5 billion, because that smart homes contains all the facilities. For example, if you are take your fan, your room light, your room fan, means we can control this room light and the fan through our mobile phone. From our mobile phone we can easily monitor that, and we can easily control that. And now the normal refrigerator is converted to the smart refrigerator. So because that normal refrigerators have some normal sensors like temperature sensors and some load cell sensors, and there are some IR sensors for detect the person. So they have some basic sensors, and after if you are applying some another one sensor, if you are connecting the another one sensors like image sensor, this camera, and we can easily monitor all the things inside of the refrigerator, and we can analyze, we can detect the object, that vegetables and fruits, like that. And after, so we can use another one technology, it's artificial intelligence. Okay, so using by this image processing technology and the artificial intelligence technology, with the use of internet of things, we can monitor our refrigerator, and we can control our refrigerator, and each and everything change into the smart things. It's only by a IoT. Okay, so next the wearables. So wearables remains a hot topic too. So as consumers await the release of Apple's new smartwatch, so there are plenty of other wearable innovations to be excited. So about like Sony smart beat trainer, and some Myo gesture control and Luxi bracelet, of all the IoT startups. Okay, so it stands at more than $500 million. So we can analyze our health data using by these wearables. So because these wearable devices have some sensors related to their healthcare, heartbeat sensor and temperature sensors like that, and it will continuously monitoring our BPM, beats per minute. Okay, and it will share to our particular cloud, our particular hospital or particular doctor, and we can see and we can monitor our personal healthcare data from our mobile phone also. Okay, so and next is the smart city. The third place, it's take a smart city. So smart city spans a wide variety of use cases. So from traffic management to water distributions to waste management system and urban security and environmental monitoring. So its popularity is fueled by the fact that many smart city solutions, so that promises to alleviate the real pains of people living in a cities these days. So because there's a lot of pollutions. For example, if you were take a simple garbage, okay, this garbage it creates more pollutants, so based on the weather conditions. Okay, and we can easily fit some sensors inside of that particular garbage, and this sensor is continuously collect the data of that particular garbage, so like gas values and the temperature and humidity level and moisture content, and it will detect the hazardous gases, and based on these details and using by this internet of things, we can send these details into the corporation municipality office, and they can take actions after that. Okay, so the main reason. And next, the traffic. So and we can give a alert to the every traffic signals using by this internet of things, and we can continuously monitoring the traffic level. Okay, so next, the smart grids. So these smart grids are a special one. So why? Because so a future smart grid promises to use information about the behavior of electricity suppliers and consumers in an automated fashion to improve the efficiency and the reliability and the economics of electricity. So 41,000 monthly Google searches highlight the concept's popularity. However, the lack of tweets shows that people don't have much to say about it, that smart grids. Okay, we can easily monitoring the electrical power theft, and we can easily monitoring the power consumption of the factories and the particular village or particular home using by these smart grids and this internet of things. So and next we can use this internet of things for industrial internet, and some for other application is a connected cars, so we can connect to the vehicles using by this internet of things. So and next, connected health. So as I'm told already, this connected health is a now is a trending one. Okay, so we can see the data from everywhere, we can monitor the data from everywhere. Okay, if you are, simply assume if you are in your home, okay, but you have some injured, so like some sick like that, okay, and you wear some smart bands, and this smart bands is continuously monitoring your body temperature and body details, and this details is sent to the cloud, and your parents and your personal doctor and your some familiar hospitals, so they can monitoring easily the your body conditions. Okay, so and the next, the smart agriculture. Okay, so here I am changed the smart agriculture. So smart agriculture is also have a some lot of sensors, I'm told, for WSN, wireless sensor network, and this all the data is connected to the cloud. Okay, so the smart farming is an often overlooked business case for the internet of things, so because it does not really fit into the well-known categories such as health and mobility or industrial. So however, due to the remoteness of farming, and the large number of livestock that could be monitor, the internet of things could revolutionize the way farmers work. So but this idea has not yet reached the large scale attention, so because we have the so we have some limited digitalized areas, so that is the problem. And this smart farming will become the important application field in the upcoming world, in the upcoming predominantly agricultural world. Okay, so and let's talk about the impact of the IoT. The proliferation of connected devices from 3 per person to today, say 10 devices per person in future. So today we are connected with 3 devices per person. In the future, so we all have 10 devices that is connected to the internet. Okay, so it will open up a lot of new opportunities for startups, and can create an ecosystem around the IoT area. So once the business value of the IoT domain is understood, new products and services and revenue models will emerge, which will attract investments and therefore create jobs in the IoT area. So this Internet of Things technology will impact the 1,20,000 jobs in the country by 2021. And this also has the potential to increase the imports or exports for the such products like solutions, so some medical exports and some food exports. Okay, so and the IoT developer, the fresher IoT developer salary in India depends on the several pivotal factors like the size and the reputation of the company. It's totally depends on that company, and the job role and job location, and the educational qualification, skill set, and work experience of the candidate. So this is the most important things for getting an opportunity in IoT field. However, rest assured, IoT developers earn more than decent yearly remuneration. So the IoT India salary study 2019 maintains that the salary of IoT professionals in India is nearly 76% higher than that the IT professionals. If you are a IoT professional, you can get a 76% higher than the IT professionals. So while IoT professionals get a median salary of 15.2 lakhs per annum, At the same time, the median salary of IT professionals is around the 6 to 8.6 lakhs per year. Okay, so there has a huge scope in a IoT area. Okay, so and I already told, when we have combined this IoT technology with other some technologies like artificial intelligence, it's changed the world. It changed all the world. So let's talk about the artificial intelligence. This is the another one, the emerging technology of electronics and the software side also. So we can embed this artificial intelligence with every one of the domain. So like electrical domain and electronics domain and mechanical domain and civilization domain. So we can embed this artificial intelligence for everyone. Okay, so basically we know that the artificial intelligence, so I am already told this data for artificial intelligence. So the main aim of this artificial intelligence is to create the intelligent machines. Okay, so they need to create the machines that have all the capabilities equal to the human. Okay, so basically so we are humans, we are totally different from other animals. Okay, so because some other animals have some basic 5 senses, and we are the human only have 6 senses. That 6 senses is an intelligent power. So using by that intelligent power, the human, it's create the another one intelligent world. Okay, so that is artificial intelligence. So they thought they need to create the intelligent machines. Okay, so for getting a intelligence, we need experience. So we need to learn more and more, then only we can get a intelligent. So for the learning process, definitely we need a experience. This experience, we can get this experience from our books, or in our school days, and from our parents. So this, from these all criteria. Okay, so because we are humans, we can easily understand these types of experiences, but that machines don't have that much of enough intelligence for analyzing the experience, because that machines knows only the power supplies now. So there's not a zeros and ones, that knows only the power supply. So we can say like that, it's only the power supply. So every machine knows the zeros and ones. If you are giving a 0, that machine will be off conditions. If you are giving a 1, then machine will be in an on condition. Okay, so using by this digital data, so digital binary data, so we need to feed up some informations, we need to feed up some experiences, so that machines convert the normal uh, digitalized data into the some analog data. Okay, so the humans converted the normal analogs data, so that like our knowledge, that like our experience, the previous experience, they're converting this experience into the digital data as a zeros and ones. Okay, and this converted experience data is fed up to the machine. Okay, and after the data is okay. Okay, so we already give a data, but that machines need to analyze the data, that machines need to think about the data. So for that thinking process, here we create another one part, that is the algorithm. Okay, so this algorithm is using to analyze all the data, and this all the data is teaching one by one into the machine. Okay, so these algorithms take a data from our database, experienced data set, experienced database, and it's teach to the machine. Okay, so that is the use of algorithm. Okay, so the sixth sense, we need to give that sixth intelligent sense to the machines, so we already done that. Okay, so the electronics industry, so if you are take a electronics industry, so it has a long standing reputation for innovation. So from the advancement in computer hardware to smartphones taking over the world by the storm, so the industry has repeatedly proved itself to be at the forefront of tech adoption. So this tech powered improvements have not only paved the path for disruption in electronics, but also turned out to be transformation in other industries as well. So it's not for only the electronics industry. Okay, so now with the emergence of new breakthrough technologies of IoT and AI, so that electronics industry is getting a reboot. That experts believe that is on the cusp of yet another major revolution, and AI is playing the huge role in these electronics industries. So, and incorporating AI is becoming high on the agenda of companies of all sizes here. The technology is transforming the business across the both industrial as well as the consumer electronics and some other electronics products and the electrical products and other software products. Okay, so the same was quite evident during the consumer electronics show CES. It was happened in 2019, so conducted in January. So from the translated devices to baby monitors and the televisions into the wrists, a number of exciting AI powered electronics devices were showcased at the event. So you can see this video in a YouTube. Okay, so just type the consumer electronics to 2019, you can get a clear information about that, and you can see the more and more electronic devices that have embedded with artificial intelligence and the Internet of Things. Okay, so and nowadays this Samsung announced that artificial intelligence capabilities would be a part of every device it manufactures by 2020. So that Samsung officially announced that informations. Okay, so however, companies are not just adding AI capabilities to their devices, but using this heuristics technology in a processors as well. In every processors, in our mobile phone processor, if you take a Snapdragon, if you take a Samsung Exynos, these are all the processors. Nowadays, all the processors have AI facilities. And this AI enabled electronics manufacturing is on the rise, and industry leaders are definitely the front runners here. So companies that front runner companies like Intel, Google, Apple and Samsung and many others have developed or are in the process of developing AI powered processors and the chips in electronics field. Okay, so basically this artificial intelligence, instead of that artificial intelligence, we have two types of process. First one is machine learning and deep learning. So machine learning is a subset of artificial intelligence. It's one of the part of artificial intelligence. Okay, so and the deep learning is a subset of machine learning. Okay, so the basic thing is a machine learning. The machines need to learn the things. Okay, so this learning process is totally depends on our amount of data. If you have a small amount of data, we can use a machine learning. If we have a large amount of data, we can move through the deep learning. Okay, so and see. And another one important process is the natural language processing, and I give an example of machine learning. Okay, the simple example. So take two sensors like temperature sensor and the gas sensors. Okay, so temperature sensor and the gas sensor. Okay, so I fit these sensors into the particular area. Okay, so and this process is for identify the fire detection. Okay, so I apply these two sensors into the particular forest area, and that temperature is whenever it will rise afternoon period and for the summer period. Okay, and the gas is also increasing, depends upon the weather conditions. Okay, but at the same time if you are getting a high temperature value and if you are getting a high level of gas value, so we can consider this as a fire. Okay, so otherwise, so you can take your own itself, so that your body temperature and your body BPM. Okay, so that heartbeat. Okay, so if you are running or if you are surrounding in a temperature area, your body will definitely get some temperatures above the normal temperature. Okay, so we can't fix that is a fever. It's only based on that temperature high. Okay, so and heartbeat, if you are in a running mode, definitely our heartbeat will be in a up and down. So and we can't fix that is a fever based on that simple heartbeat measurement. But if you are getting a high temperature and the high BP level at the same time, and the blood pressure level at the same time, so we can consider this as a fever. Okay, so for this analyzing method, so we can using the machine learning process in our hardware areas. So and the next, natural language processing and the computer vision. Let's talk about one by one. Okay, so the other important technology is the open computer vision. So computer vision, so normally human vision means we have to see the surrounding, and we have to analyze the surroundings based on our visualization power. Okay, so because we have eyes, and we have some memory power, and we have some intelligent power, so we can easily identify the surrounding objects. Okay, but how the machine can visualize that, how the machine can understand that, how the machine can classify that? So that's called the computer visions. We need to create the visualization power for the computer, for the machines. Okay, so this is the technology for that. So based using by this technology, that all the machines can see the surrounding and visualize the surrounding and enjoy the surroundings. Okay, so the main part of this computer vision is you need to feed some previous informations to the machines. It's like our AI, artificial intelligence, like our machine learning. Okay, so for example, if you are simply take your mobile phone, okay, so at the first time, so you need to register your fingerprint, or you need to register your face data. Okay, so at that time, so that registration process is getting your data, getting your face data as a database. Okay, you need to wait until that will complete the 100% while you are register your face or finger. You need to wait for 100%. Okay, so this process is the dataset collection, database collection. Okay, and this collected data is trained to the machine, trained to your mobile phone using by some algorithms. Okay, now you lock your phone, and after that you need to unlock your phone. So just you give your fingerprint on that fingerprint sensor, or give your face in front of the camera. The same process here. So it will collect your data, fingerprint data or face data, and this input face data is compared to the previous registered data, and if it was match, your phone will be unlocked. So this is a simple method. So this is the basic for every computer vision process. You need to give the exact database, and after you can access the everything in a surrounding using by the machine. And this OpenCV is having some methods, recognition method and classification method and prediction method. So recognition is for identify the face or the finger, or identify the some authorized persons. Okay, so let's talk about the security process. So first, the biometric. So this biometric authentication system is a real-time system. So it's a very, very important one. Okay, so because we have a lot of security system before that biometric, so we are using some number based pin, so that personal identity number. So otherwise we can use our some passwords like letters and the upper cases and lower cases, and this have some lower security power. Okay, so and this is not a real time also, but the biometric, this biometric authentication system is a real-time system to verify a person's identity by measuring the particular characteristics of or behavior of the scanners. Behavior of the scanners means it's a person's. Okay, and these biometric devices such as some iris detections also. So it's collect the person's biometric data and it transfer this data into the digital forms by using some algorithms to matching the patterns. And a biometric authentication system can accomplish the task of identifying or verifying the person by comparing the data with other registered biometric data in the database. Okay, so two main models of biometric authentication system is identification or verification. Okay, so in the identification mode, that input data is compared with the previous all registered patterns in the database, and this system allows to figure out whether this person is from the database. So while in the verification mode, the biometric input data is compared to the specific pattern of one person. Specific pattern of one person. So see the difference between the identification and the verification. Okay. So face recognition. So nowadays all we are using this technology in our mobile phones. Okay. So and then the fingerprint. So fingerprint is another one sector of the biometric security purpose. Okay, so and this also we are using in our mobile phones and some other ATM centers and our banks, so we can use this. And the finger vein, this is the advanced technology from the previous to face and the fingerprint. So it's a finger vein technology. However, just as we have seen in the films and science fictions, so some biometric authentication systems can be fooled by the fake resources. So for example, if you are read the novel, the Dan Brown's novel, so that name of that novel is Angels and Demons. So the assassin cut out the Leonardo's eye. Okay, so this is one of the character of that novel. Okay, so it's cut out the eye to steal the secured antimatter, and which was behind the door for opening the door. So he is cutting his eyes. I show these eyes into the retina scanners. Okay, but although biometric characteristics from the retinas are unique from each person, so hackers can also find a ways to crack the authentication system, because we can use the iris identifications also, but this iris authentications method is also sometimes it's to be fooled. But the finger vein is the top of all this. So the finger vein based biometric authentication system that we talk about, this is harder to the fooled compared to other methods. So because it's only identifies unique finger vein patterns and beneath the skin of the living person. So only of the living person. Okay. So and I heard on news before the month, the Apple invented another one security process, another one security method. So it's combined with a finger vein recognition. This also have a fingerprint and the fingerprint with the finger vein recognition. Okay, so and this I already told this iris recognition is a biometric method of identifying the people based on the unique patterns within the ring shaped region. Okay, and this region is surrounding the pupil of the eye. So every iris is unique to an individual, so making it an ideal form of biometric verifications. Okay, so one of the reasons of iris recognition is such a sought after method of identifying individuals, especially in sectors such as law enforcement and border control. So is that iris is a very strong biometric, highly resistant to false matches and the high search speed against the large databases. And iris recognition is extremely reliable and strong method to accurately identify the individual persons, but this also can be fooled sometimes. Okay, so the most important one is a finger vein. So till now there is no any method for fool this finger vein method, finger vein biometric security system. Okay, so we can use this image processor, we can use this computer vision for the security applications. And after, so we are introducing this fair and T. So this is one of the product. It's the intelligent body temperature and mask and facial recognition. Okay, so we have a capability of identifying the mask, is that person weird or not, and after wearing the mask, after recognizing the mask, it will detect the face and it will recognize the face, and it have one sensor, the temperature sensor, so it will analyze the person's temperature. So it's very useful for these pandemic situations for each and every colleges and companies or some organizations like that. Okay, so we are using this computer vision technology for this warranty. So and we can using the computer vision for the agricultural also. Okay, so nowadays the plowing and seed sowing and digging is done by using some advanced systems. Okay, the fruit classifications, so we can classify the fruits in agricultural land, and so we can detect the affected leaf, and we can detect the affected area of that particular leaf. Okay, so fruit classifications and detect the affected leaf and the leaf disease recognition. So we can using this OpenCV, this computer vision for these agricultural applications. Okay, so but still that fertilizers are dispensed in random way. Due to this, the quality of soil reduces, and it affects the growth of plants, so quality of crop as well. Okay, so that agriculture in India, so let's assume that the stage, that level of our agriculture in India constitutes more than 60% of the occupation. So it serves to be the backbone of Indian economy. We all know about it. So it is very important to improve the efficiency and productivity of agriculture by simultaneously providing the safe cultivation of the farmers also. So the objective of this project is to monitor the leaf and identify the disease in the plant for sustainable agriculture. So this fertilizing method is done by observing the leaf patterns and using the OpenCV. So by this method shows the difference between the healthy leaves and the diseased leaf. And the robot, so we can say like that agrobot will spray the fertilizer, the particular fertilizers for the particular disease. And using by this all the technologies, we can invented this type of robots. It is automatically fruiting. It's automatically identify the fruit classifications method. So using by the fruit classification method, it's automatically identify the fruits and it's automatically fruiting these fruits. And fertilizing, so it's automatically identify the affected leaf and it's automatically spray the some particular fertilizer. So based on this computer vision, so we can use these types of, and we can create, we can invent like these applications in agricultural area. So in the transportation, so transportation, in the transportations we can using the we can classify the signs, road signs, so identify the sign boards using by the deep learning method. And next, pedestrian detections, using by the some human detections, we can easily identify the pedestrian in the roads. And then the vehicle detections, we can easily identify the vehicles using by the vehicles data sets. And then land detection, and based on the efficient algorithm we can easily detect the land. Okay, so this computer vision is most and more important in the autonomous car. So using by this all the technologies that's combined with autonomous car, so we can create the autonomous car. So this autonomous car is fed up with some millions of datas, billions of driving details, and this all the driving details is fed up to the machines, and this car will move automatically. And human pose detections, using by this OpenCV, so we can analyze the pose of the particular human, and using by this technology, so we can invent that particular dressing room. So it's a virtual dressing room, so we can easily invent this using by this human pose detection. And then object detection, so based on the much of lakhs of data sets, we can detect each and every objects, that machines can detect each and every objects. Okay, and it can tell the object's name in audio output. So the even the invisible peoples also is identify, it's also getting a details about the in front objects. The blind peoples also it's identify the objects in front of them. And other technology of artificial intelligence is NLP. So NLP is a natural language processing. It's identify our natural language. Okay, so we have a lot of data, lot of previous data that was contains as a sentence and words and the speeches. Okay, so this natural language processing, or we can say like there's a NLP. So it's broadly defined as the automatic manipulation of natural language. So like speech and text, and it's by the software. So the study of natural language processing has been around more than 50 years and grew out of the field of linguistics with the rise of computers. So this natural language refers to the way we humans communicate with each other, namely speech and text. So we are surrounded by the text now. So we are mostly surrounded by the text. So think about how much of text you see each day. For example, signs and menus and emails and SMS and web pages and so much more. So the list is endless. So now think about the speech. So we may speak to each other as a species. So more than we write, we only the speech to others. Okay, so it may even be easier to learn to speak than to write. Okay, so using by this NLP, we can invented these types of devices. Okay, so Google Assistant is only, it's totally based on this NLP, and Alexa is also, it's based on the NLP. So it automatically identify your normal language. So you need to you don't need to learn about the particular sentence. So it's automatically understand your own language, and it's take action based on your recognitions. For example, if you are enter into a room, you need to turn on your fan, means you can easily say like that, turn on the fan, and Alexa, please turn on the fan. So it's automatically identify that words that you are saying, and it's converted into the digitals, and the digital is compared with the database, and finally it's recognized that, and it will give a some particular command to the particular fan model. If you want to play a song, means you can say like that, just play the song. So you can tell the song name. It's integrated with some embedded system, some electronic systems, automatically play the songs that you are record. So and see the future scope of AI. So naturally, the more varied the applications, the greater is the variation in AI job roles and their respective salary packages. For instance, well, the entry level, just minded, it's a entry level artificial intelligence salary in India for almost 40% of professionals and around the 6 lakh rupees per annum. So mid-level and senior level artificial intelligence salary could earn more than 50 lakhs in India. So in India. So in the past few years, the careers in AI have peaked to the growing demands of digitally transformed industries. So according to the 2019 report by the Indeed, the need for AI skills has more than doubled in the past 3 years. So with job postings in the domain going up by a whopping 119%. Okay, so this is the scope of artificial intelligence. We can get a 50 lakhs, more than 50 lakhs per annum. And let's talk about the image processing, digital image processing. So there is no that much of difference between the image processing and the OpenCV, but there has some slight difference. Image processing is some processing, it's some operations on the pixels. Okay, so we can change the pixels values. So that's the image processing. But OpenCV is based on the pixels values. We can't change the pixels values, and we don't need to change the pixels values. Based on the pixels values, we need to analyze the data. That's it. Okay, so this digital image processing consists of the manipulation of images using digital computers. its uses has been increasing exponentially in the last some decades. So its applications range from medicine to entertainment and passing by geological processing and remote sensing and multimedia systems, one of the pillars of the modern information society. Okay, so and there have a lot of types out there, image enhancement, and so most of us using these filters in our mobile phones, in a UCAM Perfect or some Snapchat, so like that, no? So the behind of that process, there is the enhancement type is there. Okay, so this image enhancement is the procedure of improving the quality and the information content of the original data, okay, before the processing. So and some common practices include contrast enhancement and spatial filtering and density slicing and FCZ. Okay, so this is one of the type enhancement in image processing. And next, restoration, or we can say like the restoration. So image restoration, the image restoration is the process of recovering an image from the degraded version, so usually a blurred or some noisy images. So basic image restoration techniques are survived to provide an insight into the nature of the problem. So all of we face that problems now. So these techniques also provide the solutions that are effective in deblurring blurry images with a reasonable computational complexity. So next, image compression. Image compression is the process of using compression algorithms to reduce the file size of an image. For example, if you attack your WhatsApp, if you send any one of the image to anyone, so it's automatically compressed to the WhatsApp version. This image is automatically converted to the that affiliated WhatsApp size, image or video, either. Okay, and it has two types, the lossless and lossy compression. And next to that, steganography is a very important one for the security process. If you want to share one of the data from one place to another place, from one person to another person, so we can use this steganography method. Okay, so this steganography method is for hiding the data inside of a particular image. For example, this technique of hiding the secret data, so within an ordinary data and non-secret file or message in order to avoid the detection. So that secret data is then extracted at its destination. The use of steganography can be combined with the encryption algorithm as an extra step for hiding the protecting data. Okay, and we can using the cryptography also. Cryptography means so we will merge the two images. Okay, we will hiding the one image behind of another one image. So next, watermarking. So this digital watermarking is a use of a kind of marker conveniently embedded into the digital media such as audio or video or image, so which enables us to know the source or owner of the copyright. The most of the YouTube videos, most of the YouTube content is appeared by the watermarking technology. Okay, so this technique is used for tracing the copyright infringement and in social medias, like as I'm told, this YouTube, and knowing the genuineness of the notes in the banking systems. Okay, so and so this is a thermal detector, so we can using the image processing for identify the temperature. So and before that we are using only the temperature sensor for identify the temperature, but after that, so we can using the image processing also, image processing method also for identify the temperature. So and next, so what is the carrier of this image processing? So image processing is being applied in many fields in today's world. So if you take an automotive sector, so in developing advanced driver assist for semi-autonomous car and also heavily used in autonomous and driverless cars. And we can using this for image enhancing, and we can get a job for robotics. If you are in a image processing engineer, so you can get a job opportunities for this particular image enhancing field and robotics field and gaming field. So advanced gaming consoles like Xbox Kinect uses image processing from the motion analysis of the human player. So, and the problem specific solutions and the manufacturing and the some PCB designs. Okay, so the camera simulates the eyes of a human being, so which one of the main sensor of the human body, using which brain takes the decisions. Okay, so in upcoming world, in upcoming technical world, we have a lot of opportunities for this particular image processing technology. So because all the systems are converting it into the machines, all the industries are converting it into the machine. So every machines need some visualization power. So that's why this is the most expansive technology in upcoming world. Okay, so as per the report, you can earn if you are beginner of this image processing, you can earn a 6 to 7 lakh per year. Okay, so let's talk about the robotics. So, and there is a lot of robotics out there. So I will tell some types. So it's a stationary robot, so it's non-movable robot. So these types of robots is only located in some automobile companies and some industries, automobile industries, for fixing, for welding, for screwing process. We can use these robots. And then wheeled robot, we can use this robot as a warfield robot, at the space investigator robot. Okay, and the mining robot, and legged robot, it looks like a humanoid robot, no? So we can create this robot and we can use this robot for moving the things from one place to another place. So otherwise so we can use this for some interaction process. And next to the flying robot, it's like a drone, so it's automatically flying into the forest area and it automatically capture that forest area, and it's used to detect the forest fire. So next, a swimming robot, it's like an underwater robot, it can't swim, so it is used to collect the informations under the water, under the sea. Okay, so and the humanoid robot. So humanoid robot, I already explained about this. When we are combine this AI technology into the robotic, then we can get another one human like us. Okay, so it expresses the facial expressions, that 50 plus facial expressions. The Sophia robot is the first artificial intelligent robot. Okay, I hope all of you know the details about this robot. And these types of robot is combined with a lot of technology, with all the technology. They have a cloud computing method, and it have some data mining method, and it have some artificial intelligence, and it have a NLP, and it have a open CV, and more technologies are inside of this humanoid robot. Okay, so and military robot, and we can say it on a warfield robot. So this in the robotic technology is not a new in a military applications, because in previous we have a lot of military robots. Okay, so as it has been used widely by armed forces across the world for many years. In today's globalized world, so these types of robots in the military can perform various combat roles, including the rescue task and explosive disarmament and the fire support and the logistics support and the lethal combat duties and more. So these robots can also be seen as an alternative to human soldiers, so handling a broader range of combat tasks, and from a picking of snipers to targeting the enemies. Okay, so for example, Avatar 3 is one of the name of military robot, and Togo and Gladiator and Sapphire. So these are all the name of that military robot. Okay, so skills required for the robotic engineer. What are the skills we need to know become a robotic engineer? So a robotic engineer used all his knowledge to integrate the robots and their modern technology for application in different sectors, including the manufacturing and the quality control. Some of the skill sets that are required by these professionals. So I will tell the professionals. So you need a well knowledge in the designing of robots and ability to assemble and disassemble the robots, and conduct research work in the robotic science, and testing the robots and programming them to perform different tasks, and robotic repair services and inspection of components that are involved in that robot production. So determine any malfunctions in the robot. So if we have this all the knowledge or any one of this knowledge, so definitely we can get a job in this robotic engineer field. Okay, so but we need a previous experience is must. If you get a experience and you get a more salaries in this robotic field. The average robotic engineer's salary is ranges vastly depending on the location and the experience. For example, Glassdoor. Glassdoor is one of the websites. It reports the average national salary at $75,000 per year. While Indeed is another one. So it puts the average as high as nearly $107,000 per year. And next, the VLSI. It's a very large scale integrations. The definition of VLSI is very large scale integrations. It is most important one for every electronic devices, because each and every electronic devices have a chip. So the main process of this VLSI is designed the chips. Okay, so it's integrated circuits, that's ICs. See, in 1970s, when thousands of transistors were integrated into one single chip, but nowadays we are able to integrate more than billion transistors on a single chip. However, the term VLSI is still being used, though there was some effort to kind of new term ULSI, ultra large scale integration. This is another improvement from VLSI for fine distinctions many years ago. Okay, so semiconductor industry is growing faster in India due to the technology development, and in intellectual property from the most of the companies from India provide the services to MNCs. Okay, so and you have two types, the front end development and the back end development. So in this front end development field, you have a COP with programming languages and respected to hardware descriptions language HDL for protocol designing and complex digital designs. You need a knowledge of this course. Okay, so an example, ARM processor, bus protocols and USB versions and PCIs, Ethernet, Bluetooth. For this all the process you need a HDL programming languages. You need a well knowledge in HDL. And digital design engineer. So we can be a digital design engineer. So design language most prominent on RTL, register transfer logic, and digital electronics microprocessor in-depth knowledge. And verification engineer, most of the RTL design cycles ends with only verification of design to make a bug free and reliable and time to the market. So according to the standard VLSI design process consumes 70% verifications of digital design using EDA tools, more number of demanding verification engineer. Okay, so the verification method is the very must. Okay, and back-end development. Here we know the basics flow what it contains as to the back-end development. So physical design engineer, and for the physical design engineer works on the digital design on CMOS level 1, must have sound knowledge of semiconductor and theory and somewhat network theory equipped. Okay, so professionals training it must to get into VLSI, and packages entry level from 2.5 to 3 lakhs after certain times of experience, huge hikes like in the field. Okay, and these are the major companies, multinational companies, VLSI companies with a presence in India. So they are record the lot of engineers for their own chip development, IC development. So Intel, Nvidia, and Qualcomm and Broadcom and Samsung, Texas Instruments. Okay, and AMD. Okay, these are all the processors companies. Okay, so if you are in a VLSI field, you can get a more and more opportunities for your future in these types of top MNCs. So and the next move to the communication. So 5G is the 5th generation mobile network. It is a new global wireless standard after 1G and second generation and the third generation and the 4G generations networks. So this 5G enables a new kind of network that is designed to connect the virtually everyone and everything together, including the machines, objects and devices. So both 5G and 6G, this is the upcoming network communication sixth generations, take advantages of higher frequencies on their wireless spectrum to transmit the more data faster. However, 5G occupies the broadband frequencies at sub 6 gigahertz and about 24.25 gigahertz, called low band and high band frequencies respectively. So the 6G, that upcoming 6G, will operate at 95 gigahertz to 3 terahertz. At those wavelength, 6G will deliver speeds 1000 times faster than 5G, which is only 4 to 5 times faster than 4G. Okay, because our 5G, fifth generation's wireless communication, is only 4 to 5 times faster than 4G. Okay, but the sixth generation, so this is the speeds is 1000 times faster than 5G. So top notch of the communications level. Okay, so and these all are the electronics field technologies. Okay, and I hope all of you get some knowledges about the electronics technologies and what are the technologies in the top and what are the companies are recruited the electronics engineer for some reputed domains. Okay, so and if you have any questions related to the topics or technologies, so kindly mention it in a chat box. I will reply at the end of the session. Okay, and guys, I hope all of you enjoy this session. And here we are here for supporting you for your upcoming technical aspects, Internet of Things, and in the field of Internet of Things and artificial intelligence and robotics and wireless sensor networks and computer vision and image processing, VLSI and wireless communication and antenna devices. So we are supporting these all the technologies to all of the engineering students and the arts college students for your technical improvement. If you have any queries about this session and these technologies, so kindly call this display numbers. So we have a head office in Tamil Nadu. So second floor, Sai Studio Complex, Ramnagar, Kandipuram, Coimbatore. And if you are from Kerala, you can call this another two numbers. It was located in a number 65, 707 basement floor, and Kalur Towers. It's opposite to the AJ Hall, KK Road, Kalur, Kochi. And guys, if you like this video, kindly like this and share this video with your friends for getting the knowledge. And if you are new to this channel, kindly subscribe us for click a bell icon and click a bell icon for getting notifications of our upcoming videos and technical events.